The first thing we're going to look at are the zeros. The zeros are the places on the graph where the blue part of the blue graph, the curve, crosses the x-axis. So I can see that it crosses here at -1, and it also crosses, it doesn't exactly cross, but it touches here at 2. And when you have something like this where your graph just touches, like it goes down and then it bounces right back up off the x-axis, or it could, be come up and then touch and go back down like that. When you have something like that, it's actually called a double zero. So even though you can only see it once, it means that it's actually a double. So I'm going to put double. It actually counts twice. The least degree, you look at the number of hills and valleys, and then you always add 1. So I'm going to make a little note here, is that the degree is the number of hills plus valleys, and then it's always 1 more than that. So I see a hill and a valley, so that's 2, and then you add 1, so that would be 3. So the least degree would be 3, which you can also see if you look at the zeros. There are 3 zeros because that 2 counts as a double. Okay, least degree is on there twice, so I'm going to cross that one out. And we're going to go right to minimums. The minimum, I'm looking for the ordered pair. So the minimum actually happens to be the same as that double zero. So I'm just going to put a green box around it. So the minimum value would be at the point 2, 0. And remember, when we talk about minimums and maximums, we're really talking about relative minimum and maximums. I know that this graph goes down to infinity, negative infinity forever and ever, but I'm not talking about what happens on the ends. I'm talking about kind of what's happening in the middle. For maximum, it's kind of the same deal. I'm looking for a relative maximum, and that one happens right here, and that is at the point 0, 4. So that's the highest point on the graph if you don't include this arrow that goes up to infinity. All right, now the domain and range are actually both going to be the same thing. And the reason they're going to be the same, they're both going to be all real numbers. The reason is, if you look at your arrows on the right side of the graph, so I'm looking at this arrow over here, it's going to keep going, it's going to keep getting wider and wider, so it's going to keep going to the right towards positive infinity. If you look at the left side of the graph, that arrow is also going to keep going to the left towards negative infinity, so it covers all the x values. And then if you look at those same arrows, they're also both, the one on the right is also pointing up forever, and the one on the left is pointing down forever, so it's going to cover all of your y values as well. Now we need to talk about end behavior. We're always talking about as x goes to negative infinity, which is to the left, and as x goes to positive infinity, or to the right. And then I want to look at what my y values are doing. So my y values, I'm going to look at the left side of the graph first. So I'm going to look over here where I'm drawing this pink star. If I look at the left side of the graph, this arrow is pointing down. So my y would be going towards negative infinity. If I look at the right side of the graph, which I'm drawing, where I'm drawing 2 pink stars, my arrow is pointing up, so then that y value would be going towards positive infinity. Now the last thing we have to talk about are the increasing and decreasing intervals. So what I'm going to do is I'm going to draw dotted lines through our maximum and our minimum. So I'm drawing in this dotted line, which is a little hard to see because I'm going over the y-axis. And then I'm drawing another one here, which got a little crooked. Okay, so that breaks up my graph into 3 sections. So I'm going to highlight my first section, so that's all the way from negative infinity until I hit my first boundary line. And then I'm going to do this section of the graph in blue, and then I'm going to do this last section of the graph in green. So I have 3 sections. What I want you to do is imagine that you are walking on this graph. So this is you. And if you're walking to the right, so if you're following the graph, you have to try to imagine, would you be walking uphill or downhill? Uphill means increasing, and downhill would be a decreasing interval. So I'm looking at the yellow interval first. And that one, if you were walking on it, you'd be walking uphill. So that would be considered an increasing interval. So for the yellow one, if you started all the way off to the left, and by the way, when we do increasing and decreasing intervals, we are only talking about our x values. Those are the only things that are going to go in our intervals. So we're going to start at negative infinity, and we would stop increasing when you get to the maximum, and the x value there is 0. So that would be an increasing interval. Now if you look at this blue interval, that one is decreasing, because if you were walking down, if you were walking on that part of the graph, you would be walking downhill. So the blue part of the graph is a decreasing interval. So I'm going to write decreasing, and that one starts at 0 and it stops at the x value of 2. And then our last interval is the green one, and that one is increasing again, because if you were walking on the graph, you would be walking uphill. So that one starts at 2, and then it would follow the graph all the way to positive infinity.